We'll start the class. In last class, we discussed about compaction and we left it with some concept that is shear strength. Today, we will cover that concept and we will go ahead with one more concept. That is shear strength of the soil, direct shear test, vane shear test, triaxial test. Today, we will be covering. And after this, we will go earth pressure theories, active and passive earth pressure theories. This much we will cover. Tomorrow, Sunday, I will take 1 hour class. In that 1 hour class, I will cover capacity, this bearing capacity and plate load test, standard penetration test. Okay, now we'll go ahead with the shear strength of soil. Okay, the shear strength of soil here always in strength of material or otherwise when you are handling any material, then you will worry about their strength because you have to apply stress on the material. Therefore the material has to ready to take that load. That readiness of the material is called as a strength. Readiness of a material is called as a strength. Here I would like to explain you the difference between the stress and the strength. Okay, stress and strength, that difference we will understand and we'll go ahead with this chapter. Let us consider there is one human being, and human being is there. On his head if I put 1 kg stone, then he is not dying, he is alive. Then the 2 kg alive, 3 kg, 4 kg, 5 kg, he is alive, right? When I apply a 6 kg stone on his head, then he will die, right? Means I can say that this 6 kg is the failure load. This 6 kg is what? 6 kg is a failure load for that human being, right? Now I can say that the capacity, maximum capacity of this human being, the maximum capacity of this human being is 6 kg. This one I can say that this 6 kg is considered as a strength of the human being. Strength of human being, or some textbook they will say that 5.99 kg is the strength of the human being and 6 kg is the failure load. They are somewhat very nearly, they are equal to each other. 6 kg or 5.99 kg, they are nearly equal. Now look at here, whatever the load you are applying from the top is considered as the load which is applied on the top is considered as a stress. This 6 kg is considered as a stress, and this 5.99 kg is considered as strength. 5.99 kg is considered as a strength. Now whatever the external load you are applying, external load what you apply, that is considered as a stress, and internal resistance that will build, and this internal resistance I will put it as a maximum internal resistance developed is called as a strength. Okay, if the stress has a unit Newton per meter square, then the strength is also having the Newton per meter square. See, in strength of material or otherwise while dealing any material, you will be discussing with some strengths. For example, compressive strength. Compressive strength means the material is ready to handle the compressive load. Then we will deal with the tensile stress. Then the material is ready to deal with the tensile forces. Then there is another called as a torsional strength. Torsional uh, Torsional strength. Then the material is ready to handle the twist or torque applied. Then we have shear strength. Shear strength. Okay, shear strength means material is ready to resist the load in terms of shear. Let us consider this one first, because in this chapter we are discussing with the shear. Why we are interested in shear? Why not this geotechnical engineering? Why we are interested in shear? Why not we are interested in compression or tension or torsion? We are not interested on these three type of stresses or strength. We are interested in shear strength. Why? Because our material is a granular material. It is not a compact or intact material. Compact or intact material means I will give an example of steel. this steel rod is there. Now this steel rod is considered as a compact or intact material. You will not find any voids between the within the material. Therefore, this is considered as a intact. But here the soil is not intact material, it is somewhat liberal or otherwise granular material. When I apply some load on the soil, let us consider when I apply this load on the soil, then the soil will resist in terms of shear, because this particle will rub with this particle and it will create some rubbing action between the two particles. That is considered as a shear. Therefore, each and every particle will offer the rubbing action for the load applied to the soil. Therefore, the collectively the rubbing action of all these particles, that is considered as a shear strength. Why? Because this is a rubbing action is there. That's why I am interested in shear, and the strength of the material is in terms of shear. Therefore, it is shear strength. Now you have to take care of this one. Look at here. You are applying compression load. You are applying compressive stress, but the resistance offered is a shear strength. This is very interesting in terms of soil. Here in steel, what happens? You apply compressive force, and inside also compressive stress will develop. If you apply tension, then inside also tension will develop. But in terms of soil, what happens? You may apply shear stress and you may apply normal stress, and both will be resisted by shear strength. Therefore, whenever I deal with the soil, then I have to deal with the shear strength, not other strengths. Understood? Because here one particle and another particle directly they will not resist in terms of compression or tension. Therefore, we have to deal with the shear strength. This shear strength was first discussed or otherwise studied by Coulomb. The scientist, the Coulomb was the first person who studied this shear strength. According to him, the structure, the according to him, whatever the force you apply, okay, we will not consider him first. Before that one, I will further introduce you shear strength. Then later I will bring this fellow. Now look at here. We are interested in shear strength. Then what that makes the soil become more good at shear? Let us consider the same diagram. This is one this load I am applying, and inside we have a soil here. These are the soil here. These are the soil particles, and when I apply this load, then there will be a resistance. Then resistance, how many types of resistance we will be getting inside is, the first one is frictional resistance. The first one is called as friction, frictional resistance. Frictional resistance. Frictional resistance means, see here, every particle will have a rough surface, right? This green color you can see, this particle is a rough surface, and this particle also has a rough surface, and this particle also has a rough surface, this particle also has a rough surface, and these all rough surfaces are, they are in contact. They are in contact. When I apply force, then this rough surface will resist this rough surface. Therefore, there will be a frictional resistance will be developed. Then this total force whatever you are applying, that will be resisted by frictional force. This frictional force is measured in terms of phi. This phi is considered as angle of internal friction. Angle of internal friction. Right? Then the second term is every particle. Now I will explain with the blue line. The every particle will possess a cohesion. This particle has a some cohesion. This particle has a some cohesion. Means they will attract each other. They have attracted each other. This particle also has a some cohesion. They have attracted each other. This particle also has a cohesion. This particle is a cohesion. Therefore, they are all attracted to each other. Now, this attraction will also resist the force. Therefore, that second one is considered as a cohesion of the soil. This cohesion of the soil is considered as a C, that is measured in terms of C. Then we have a two major parameters, that is your soil is resisting through the frictional resistance or cohesion. The another one is there interlocking. The third one is interlocking the particles. Interlocking of particles. interlocking of particles. Let us consider the one particle is like this and the another particle is like this. Both are interlocked, no, because I don't know inside what happens, and this is interlocked and another particle is inside like this. Then when I apply here, they might be smooth or they might not have a cohesion, but still because of the interlocking, then they are resisting the external force. Therefore this is called as interlocking of the particles. Okay, when I study the strength of the soil, then I will not consider this interlocking because I am not sure about this one. No, I am not that confirmly that is sure about interlocking of the particles. Therefore, I will not consider. Therefore, according to me, the shear strength means that is a cohesion, and the shear strength means that is a angle of internal friction. Okay, this is the theory about shear strength. Understood? Now, how to establish how to determine this angle of internal friction or otherwise that cohesion? For that one, the first scientist who studied on this one is Coulomb. The Coulomb's theory will come. Coulomb's theory will come. Coulomb, he did one experiment on that. Then, according to his experiment, he has got some conclusion. That conclusion I will explain you with. I will explain that conclusion with some small video. 1 minute. Can you see my hand? Now concentrate on my video rather than that this one PPT. Concentrate on my video. 1 minute. Okay, make it big. Now look at here. This is the video. Now if I pull this one, then it is easily coming, right? This is easily coming out of my hand. Then if I apply some force here, this is the normal stress I am applying, this is also normal stress I am applying. Then if I pull, it is not coming suddenly. The material is same, my hand is same, and this charger is also has some surface here, and this material is same. But initially it was very easy, means there is no shear resistance between the charger and my hand. But the same material will possess your shear strength when I apply compressive stress. When I apply lot of compressive stress here, when I pull this one, then it is not suddenly coming because here the resistance is coming. That is your friction is coming here that will stop this charger to come out. Right? From this what we can understand is the shear strength of the material is not constant for a particular material. Understood? Very important is the shear strength of the material is not constant. Remember, the strength of the steel, if you ask me what is the strength of 415 steel, no, if you ask me what is the strength of 415 steel, then I will say that the 415 steel strength is 415 Newton per mm square. What is the strength of the 250 steel? Then I will tell this is the Newton per mm square. What is the strength of M20? Then 20 Newton per mm square, like that. But if you ask me what is the strength of the soil, particular red soil, black cotton soil, then I will not tell you what is the exact strength of the soil. Why it is not possible? Because that is also depending on this strength is also depending on the normal stress. Say for example, this is a charger, otherwise this is a soil. Then when I apply the normal stress here, then the normal stress is applied. When I pull this one, if this force is more, then it will not come easily. Not come easily. Right? If I make it loose, then it will come easily. Then see here, the resistance is depending on the normal stress. This much was studied by this Coulomb. Coulomb said that shear strength of a material is depending on the normal stress applied. Normal stress applied. That is very important. Means according to Coulomb, he said that shear strength of the material is directly proportional to, sorry, it is a function of normal stress. He just said a function of. Function of means what? It is something depending on the normal stress. How it is depend, how exactly it is depend, he did not explain this one, but the next scientist who came, his name is a Moore. Now we have heard Moore circle, that Moore only. This Moore, he introduced, he considered this normal stress and shear stress and shear stress. Then he studied, he did many experiment on this normal stress and shear stress, their behavior, and he come to know that he also agreed that the shear stress is directly proportional, or otherwise it is a function of normal stress. Then according to this Moore, what he did experiment is, I will explain you the direct shear test. Now only direct shear test. Then in this direct shear test, what we do here is, see here, I will just come back to this more later. Now I will explain first direct shear test, then I will come back to the Moore's concept of shear strength. Why? Because Moore did a direct shear test, and that we are using it later. Right? Now to explain this Moore's test, I will go to the laboratory. Now look at here. You can see these apparatus in the laboratory. This is considered as a shear box, or box, square box, or it is also considered as sorry, this is called as a shear box, and this is just a mold. This is just mold. Right? Now this is a mold. See, this mold has a sharp edge at the top. You can see there is a sharp edge here. There is a sharp edge at the top, and this one we will put it on the leveled ground. This is a leveled ground. Then we will put that box here, the sharp edge at the bottom, sharp edge at the bottom. Then we will hit it inside by using some hammer, or otherwise some this one compressor. Then we will put it inside this. A small square box will go inside the soil. Then we will excavate the surrounded soil. Then we will bring this back to laboratory. This is a one way of getting the soil sample. The other way of getting soil sample is, take this soil sample, and with the help of this wooden this one rammer, then we will put a soil here. Then using this one we will compact it. Then we'll put a soil here, then compact it. To put a some small amount of soil here and put a compact. Do the compaction. Then you have prepared a full of soil, and that soil we will transfer it to this tray. Okay, how we have to transfer it, and exactly those things will be explained in the laboratory. For competitive exams, you just remember that there is a square mold. In that one, soil is compacted or taken from the ground, and that will be transferred to the shear box. How it is transferred, that method and all, you can see it later. Now the soil is transferred to this mound. Then after that, at the top and bottom we will put this porous plates. These are all called as porous plates. Top and bottom we will put a porous plate, and after that top and bottom we will put growing plates. We will put a top and bottom growing plates, and this square pedestal, that we will put it on the top. We will put it on the top. The entire assembly, the prepared assembly, will sit here. You can see here the entire assembly is sitting at this point. Right? Then after that we will arrange some loads and all, and this is a normal load. We will arrange some loads and all. Then after that we will test the sample. Okay, now I will explain you how exactly theoretically the direct shear test will be dealt. Right? Now look at here. This is your box shear. Inside a soil is there. You already seen the box shear. The box was uh, two halves, which is made up of two separate plates. Like this, the box shear will be there. Means this is separate, and the bottom one is a separate. But the soil is intact here inside. Then after that, above you will put one porous stone. Above that you will put one a plate. Then below you will put one porous stone. And this entire assembly will be kept on rollers. Entire assembly is kept on rollers. And this roller is kept with the stand. This one frame. Loading frame, we will keep it here. Right? Now here you will apply normal stress. This is called as a normal stress. You are applying normal stress. Now you will apply shear stress. This normal stress is considered as constant for a particular test. Then you will apply one force here and one force to the top, one force to the bottom and one force to the top, so that it will break in shear. One force will go like this and one force will come like this, right on. Therefore it will break like this, top and bottom, right on. Now when you apply this force, then the top layer may be like this and the bottom layer may go like this, means inside you have got a shear failure. You are inside, you have got a shear failure, means you have measured how much stress it has taken, that is a toe. You have did a experiment here very interestingly, that is for a normal stress for a sigma 1, then you have got toe 1. This is the first experiment. Okay, then after that you will increase this load. Earlier if you taken 1.5 kg per centimeter square as a normal stress, then here it may be about 1 kg per centimeter square as a shear strength. Now see here in the table you have got this way, that is 1.5 normal stress you applied kg per centimeter square. For that correspondingly you got 1 kg per centimeter square as shear strength. This is one experiment. Then after that you will do another experiment. In that another experiment you will apply, you will increase the load. You will apply 2 kg per centimeter square, let us consider. Then there will be increase in the shear strength. It might be 1.3 kg per centimeter square. How much I don't know, this just roughly I am explaining. Next time you may increase 3 kg per centimeter square, then you will get a increased shear strength, that might be 2.2 kg per centimeter square, right? Like that you will do many experiments. Usually minimum 2 experiments you have to do, or minimum 3 experiments you have to do, right? Then after this one you will draw one graph. This graph is considered as, I will show in the other page. This graph you will draw. This graph is a Morse graph, therefore the x-axis is a normal stress, that is your normal stress, and the y-axis is your shear stress. Y-axis is shear stress. Then see here 1.5 was there, 2 was there, 2 and 3 was there. Now that mark you will mark here, because you have got 3 points, then one first point, second point, third point, like that you will mark. Then you will join these three points. You will join these 3 points. Then after that it will cut in the y-axis. Then this y-axis intercept is called as a C, and this angle is considered as a phi. The C and phi. Now look at here, these stresses whatever you apply here, this is a failure stress, agree? That is your failure shear stress. Failure shear stress is nothing but what? Strength. That is nothing but strength. Therefore I will call these points are strength points. These points are strengths. Therefore I will call this one as strength envelope. Strength envelope, or it is also called as failure envelope. Failure envelope. Strength envelope you can call, otherwise failure envelope you can call. Now you have got this one. Then what is the C and phi? Before that one I will explain you what is the equation of this curve. The equation of this curve, how to obtain the equation of the curve. Now this is something look like a x and this something look like a y. Therefore this is a straight line. Then y equal to mx plus c is your straight line equation. I will rewrite it, c plus mx. Then here y means what? In this our graph, y means shear strength. Then c means that is intercept c, as it is c. Then m means that is the slope of this curve. This slope of this curve I can consider it as a tan theta. Tan phi is the slope of the curve, therefore that is your tan phi. Then this x means x-axis is a normal stress, therefore this is normal stress. This is your ultimate equation. This is called as a, now I will call it as a Morse equation. Morse equation. Okay, later I will consider call it some different name. Just now don't by heart this one. This is not a Morse equation. For time being you can consider it as a Moore equation. Later we'll consider, we'll give another name. Right? Now this is your C plus sigma tan phi means what? From this what you can understand is tau is equal to plus sigma. Then what is the other terms? Other term is C plus tan phi. Now this C and tan phi are called as constants. They are constants. Okay, now as you increase the normal stress, then shear stress will also increases. Then as you increase the normal stress, shear stress will also increases. Therefore you have got this equation. Understood? Now I will come back to the Morse concept. This is all about a direct shear test. I will come back to the Morse concept. In that Morse concept, what he said is this experiment is done by Moore. Then Moore said that tau is directly proportional to normal stress, or tau is a function of normal stress. But look at here. According to Moore, according to Moore, the graph will come. The graph will come like this. What? According to Moore, the graph will be this one. That is a slight curve will come. Slight curve will come according to Moore. Okay, now, but according to Coulomb, according to Coulomb, Coulomb means who gave first theory. No? According to Coulomb, this curve is not like that. He said that it is a straight line. It is a straight line. This is a straight line according to Coulomb. Remember, you have to remember according to Moore, curve according to Coulomb, it is a straight line. But Moore, when he said that curve, it is a curve, then he is not able to, or otherwise, it is very difficult to give the equation for this curved line because it's not exactly parabola, it's not exactly a circular, or it's not exactly a hyperbola or something. That's why it was very slight curve. Therefore, later Moore will agree with Coulomb's theory. Then after that, both together they will consider it as a Moore Coulomb theory. Moore Coulomb theory. Coulomb theory. Then Moore Coulomb theory will be that whatever we have discussed, that is your tau shear strength is equal to C plus sigma tan phi. C plus sigma tan phi is considered as Moore Coulomb equation. That is called as a Moore Coulomb equation. Right? This is a Moore Coulomb equation. This is Moore Coulomb equation where C is a cohesion, phi is angle of internal friction. Angle of internal friction. Right up. Now there is a one big question here. C and phi.
ಸರ್ ಸರ್ ಇನ್ನೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಸರ್ ನಿಮ್ದು ವಿಡಿಯೋ ಸ್ಟ್ರಕ್ ಆಗೈತೆ ಸರ್
ಓಕೆ ಎಲ್ಲಿಂದ
ಇದು ಇಕ್ವೇಶನ್ ಬರೋದಾದ್ಮೇಲೆ ಸರ್
ಈ ಇಕ್ವೇಶನ್ ಬರೆದ್ಮೇಲೆ
ಇಲ್ಲ ಸರ್ ಇದು ಶಿಯರ್ ಸ್ಟ್ರೆಂತ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸಿ ಪ್ಲಸ್ ಟ್ಯಾನ್ ಫೈ
ಓಕೆ
ಅಲ್ಲಿಂದ
ಮೀನ್ಸ್ ಇನ್ ದಿಸ್ ಸ್ಲೈಡ್ ಓನ್ಲಿ ನೋ
ಹಾಂ ಸರ್ ಇಲ್ಲಿಂದ ಸರ್
okay see here I just wrote this is a Moore Coulomb equation. Why? Because the standard test was explained or predicted by the Moore. This test was predicted by the Coulomb, and later experiment is done by Moore. But according to Moore, this is a slight curved, and according to Coulomb, it is a straight line. But Moore, whatever he considered a slight curved, no, but he was unable to give the exact equation for this slight curve. That's why both together they will agree with the one concept, that is a Moore Coulomb theory. This much. That is tau s equal to C plus sigma tan phi and is considered as a Moore Coulomb equation. Then C is a cohesion and phi is the angle of internal friction. Right? One big question what we have to think about is whether this C and phi are constant. Are these constant? The question. Okay. When you look at this, are these constant? for a particular soil? For a particular soil, this is the question. What do you think? Because here the variable is sigma and variable is tau. This is a dependent variable and this is independent variable. Correct? Now, what do you think of C and phi? Are they constant for a particular soil or not? Anyone? Are they
No,
constant?
no,
No?
no.
How?
Constant.
Lakshmi, can you explain why it is not constant?
It depends on the normal stress.
No, that shear strength is depending on the normal strength. But C and phi, others,
So constant.
they are constant.
Yes, sir.
Okay. See here, this is a challenge here. The challenge is, it is both answers are somewhat right. That is there. They act like a constants also, and they are not constants also. Then how to deal with this one, both constant and not constant? Because here C and phi for a particular soil, because see here, this is one test, this is a second experiment, and this is a third experiment. These three experiments I have done on a soil, on a particular soil. Let us consider this is for red soil. Right? This is for red soil. I have done three experiments. Now, for the red soil, these three are in one line. They are in one line means C and phi are constant. Now, the challenge is, if I consider this red soil and do a triaxial test. Do triaxial test. Then when I do triaxial test, then I will determine C and phi value. Then this C and phi value is not like this C and phi value. They are completely different. They are completely different. Now I can say that this C and phi value is constant for a particular soil for a particular test. Now I have to add one more thing. For a particular soil, for a particular test. This test you can consider it as a for a particular condition I can consider. For a particular condition. Then the scientist was very interesting. How come the C and phi is different in direct shear test and the values are different in triaxial test? Then they have done one more test. See here, direct shear test, and later they have done for triaxial test. But now for this triaxial test, they have done with another one that is called the drained test. Drained test means in the triaxial test they will allow water to pass through. Allow water to pass through, then they have determined C and phi value. Then the C and phi value again different. Then here also the different, and here also C phi is different, and here also C phi is different. In three different cases, the three different C phi values we got for a then whether they are constant or not. Then I have to wisely answer this question whether C and phi for a particular soil is constant or not. For that, the answer is they are constant for a particular test or in a particular condition, then and in a particular drainage conditions also, in a particular drainage condition also. Why it is like this? Because that I will explain at the end of this chapter. No? Because I will explain you triaxial test, unconfined compressive strength, then later we will discuss why the C and phi are different for a different test conditions or otherwise drainage conditions. Right? Just now you just remember that is C and phi are not constant. They depending on the tests. Okay now. Now I have explained you that try direct shear test. One more thing I have forgot. See here, this was your top sample and this was your bottom sample, right? When you pull this, sorry, when you push this one this side, and the bottom was pushed here, then you have got shear in between the two parts of the soil. Now here the failure plane is horizontal. Failure plane is horizontal. Failure plane is horizontal. One more very important thing is that failure plane is horizontal and it is predetermined. It is predetermined means because you are applying the forces in horizontal direction means it has to fail in horizontal direction. Therefore, it is predetermined. Predetermined, right? Then this one and this one is considered as a drawback of this test. Drawback of this test. Why? Because it is predetermined. I don't know whether it might this soil wanted to fail like this. The soil wanted to fail like this, wanted to fail like this, but you are forcibly making that soil to fail in this way. Therefore, this test has some demerit, that is failure plane is horizontal and it is predetermined. And the third one is very important is the horizontal horizontal failure plane may not be weakest plane, that may not be weakest plane. And the fourth one is very important demerit. The demerit is you are not considering the actual rubbing area. See, this area you have to consider, no? This is one part and this above that one another part is there, but when you apply the load it is sliding like this, means this area you have to consider, but you are not considering the actual area. Therefore, cross sectional area calculation is also one of the demerits, one of the drawbacks, one of the drawback, right? These are the drawbacks, and by using one of these drawback, that is the horizontal plane, horizontal failure plane is there, no? Failure plane is there. That one, for that one, if I draw more circle, because determined by more one, the first, second, third, 3 points you will get. Then for a particular soil, you will draw perpendicular line from the failure plane, then you will consider it as a center C, then this as a radius R, then you will draw one more circle, and wherever that cuts in the x axis is considered, the smaller value is considered sigma 3 and the sigma 1, and the sigma 1 and sigma 3 is considered as principal stresses. Principal stresses. Then sigma 1 is considered as a major principal stress and sigma 3 is considered as a minor principal stress. Right? And horizontal failure plane you will draw here and you will get one pole point here. Then if you join this procedure, if you follow this procedure, then this angle is considered as alpha 3, alpha 3, and this angle is considered as alpha 1. Then alpha 1 and alpha 3 are orientation of orientation of principal planes. Orientation of principal. Do you have any doubts in direct shear test? You can ask. If you want to ask anything, you can ask in direct shear test.
ಸರ್ ಅದ್ರೊಳಗೆ ಶಿಯರ್ ಸ್ಟ್ರೆಂತ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಹೆಂಗೆ ಸರ್?
Shear strength calculate ಮಾಡೋದು ಹೆಂಗ? 1 minute. Shear strength calculation is same. You will draw the 3 points now. First you will take 1 point, 2 point, 3 point, you will draw, then you will join these curves, then you will get a phi value here and you will get a C value here. Then you have an equation here, that is tau is equal to C plus sigma tan phi. Then let us consider this C is a 50 and this one is a 15 degree. 15 degree. Then you have got a tau equal to C means what? How much? That is 50 plus sigma tan 15 degree. This is your equation, because shear strength, as I already told you that shear strength is not constant now, because it is depending on what? Normal strength. Then you take, say for example, your foundation is giving say 120 kilonewton per meter square. You are applying 120 kilonewton per meter square your load. Then what is the shear strength? then shear strength equal to 50 plus 120 tan 5, 15 degree. The answer. Right? Any doubt? Here you should get one doubt. If you have that doubt, I will answer. I will go further.
Sir,
Ah,
sir, is it possible to perform drain and drain test in direct shear test?
no, no, no. It is exact. Actually, your question is valid. The answer is no, considering textbooks. Considering textbooks, I can say the answer is no, because earlier days it was very difficult to determine drained and undrained test by in a direct shear test. But nowadays in IITs, if you go there, then you will see the answer is yes, because advanced direct shear test apparatus are coming. Therefore, it is yes. Therefore, what you have to answer is here. It is complicated. You can consider complicated. Right? Any other doubt? Hmm.
ಸರ್
Yeah.
ಸರ್ ಅದು ಗ್ರಾಫ್ ಒಳಗ
Hmm.
y ಆಕ್ಸಿಸ್ ಶಿಯರ್ ಸ್ಟ್ರೆಂತ್ ಏನೋ ಇದೆಯಲ್ಲ ಸರ್,
ಹೌದು, ಶಿಯರ್ ಸ್ಟ್ರೆಸ್.
ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಅದು ಹೆಂಗ ಇದು ಮಾಡುತ್ತೆ ಸರ್,
ಅದು ಹೆಂಗ
ಲೊಕೇಟ್ ಮಾಡುತ್ತೆ ಸರ್ y ಆಕ್ಸಿಸ್?
ವೈ ಆಕ್ಸಿಸ್ ಒಳಗೆ ಇಲ್ಲ ಇದಲ್ಲ. ಸಿ ಹಿಯರ್, ದಿಸ್ ಇಸ್ ಯುವರ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. See this experiment. You concentrate on green lines. Concentrate on green lines. You will apply normal stress na in the equipment. Look at here. Wait, wait. See here. The concentrate on green line. See, this is there. No, this is a normal stress. You will put a load here. This load will be applied in the top. Like that, this arrangement is made. Don't worry about the arrangement. Whatever the load you are putting here, that will be applied in the top. Correct? Now you are applying here 1.5 kg per centimeter square. Then after that, here one machine is there. Okay, here one machine is there. This machine will push the load. This machine will push this horizontal load. Okay, then when it breaks at this point, then the machine or a proving ring will give you this load, that is your shear strength, shear stress at a failure. Then you have got 1.5 and the failure one, that you will write it in one table. The first experiment you will call it is, and you will write 1.5 and 1. Then after that you will increase the this load, you will increase this further load, that is 2 kg. Then when you do a 2 kg, then this machine will give, motor will give you another load. Then that way you will write. Like that you will do 2 or 3 experiments. Right?
Yes sir, yes, got it.
Okay.
So can you quickly brush the last graph, that principal stress and
This one. Okay.
alpha 1, alpha 2?
Yeah. With this one, to understand this, why we have to draw more circle, for direct shear test, that we have to understand. The theory is here one, this one is there, see here, demerit. The demerit is the failure plane may not be the weakest plane. The failure plane may not be the weakest plane. I will give you one story here. One story I will give you, that there is a room here. In this room there are some people. Let us consider this person. I will give you a stress as a homeworks. This person can do 4 homeworks. If I give 5 homework to this person, he will die. Okay, this person 5 homework, this person 6 homework, this person 8 homework, this person 1 homework, sorry, 2 homework, and this person can do 6 homework. Now if I give more than their corresponding homework, then they will die. Understood? Okay, means for this person, if I give 6 homework, then he will die. Okay, if I want to give a group homework, if I want to give group homework, then make sure that no one will die. Then how much I have to give? Any answer? Group homework. How many homeworks I have to give so that no one will die?
Every
Average.
No, not average. If you give average, it might be 5.5. Then if I give 5.5 average this homework, then the 4 fellow will die and 2 fellow will
It
also
should
die.
be the minimum, sir.
Which should be the minimum. Minimum means how much? Here in this group, the weakest person is who? This person is the weakest person. Then the weakest person's strength is a 2. Then if I give more than 2 homework, then this person will die. Then the condition is this person should not die means what is the strength of this entire group? I can say the strength of the entire group is 2. How you decided the strength of the entire group? By seeing the weakest person. By considering the weakest person, you have designed the strength of the group. Like that, the soil may have this one. In this soil, this plane may have some different value of shear. This will have different shear. This will different shear. This is different shear, and this is different shear. Let us consider this plane might be the weakest one. This plane might be the weakest one, but you are not concentrating on the weakest plane, but forcibly you are applying for load and you are making this person to die. Therefore you are not getting the exact strength of the soil because your focus is not on the weakest person. Understood? Why this you have got it as a doubt, this is a demerit, because you are not concentrating on weakest person. Actual thing is you have to concentrate on weakest person. Okay, now then how to address this problem? How to address this problem? For that I will draw more circle. I will draw more circle. In this more circle, I will get a 3 points here. Sorry, this 3 points here. I will draw a curve. Then I will get 1 point here. Okay. See here, this is considered as a tangent. This is considered as a tangent. Tangent to the more circle. Tangent to more circle. Then where is the more circle? I don't know. But I have a mathematically I have a relation that is a tangent and a circle. Tangent and circle, they are perpendicular to each other. This relation I will use and I will draw one perpendicular line from this line. This point I will draw one perpendicular line. Then I will get a center here. Then I will consider it as a radius. Then I will draw one circle, semicircle here. You can complete this circle drawing below also, but I will not draw. Just I will draw here. Then this point is considered as a failure points. Failure points. Now look at here. Failure points means at this point you have got sigma and tau. Right? This is corresponding tau and this is corresponding sigma. Means this is the combination. This is the combination you are getting the failure. Okay, now then what is the maximum normal stress that I can apply on this soil? The question is this one. What is the maximum normal stress that I can apply on this soil is this much, not this much. See here, this is here sigma, but this is sigma 1. This is the maximum possible. That's why it is called as a normal maximum major principal stress. What is the minimum stress I can apply? This is your minimum stress, sigma 3. Sigma 3. But here there is another stress. This is considered as a maximum shear stress. This is tau max. Understood? See here, shear strength chapter is all about combination. Shear strength of a soil is all about combination. ಕಾಂಬಿನೇಷನ್. ನಾನು ನಿಮ್ಗೆ ಒಂದು ಫನ್ನಿ ಸ್ಟೋರಿ ಹೇಳ್ತೀನಿ. ಓಕೆ, ಫನ್ನಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. ಇಲ್ಲಿ ನಮ್ಮಲ್ಲಿ ಒಬ್ಬ ಮನುಷ್ಯ ಇದ್ದಾನ. ಓಕೆ, ಇವ ಒಬ್ಬ ಮನುಷ್ಯ ಇದ್ದಾನ. ಇವನಿಗೆ ಶಿಯರ್ ಅಂತಂದ್ರ ಅರ್ಥ ಬೈಯೋದು ಅಂತ ತಿಳ್ಕೊಳ್ರಿ. ಇದು ಕಪಾಳ ಕೊಡಿಯೋದು ಅಂತ ತಿಳ್ಕೊಳ್ರಿ, ಕಪಾಳ ಮೋಕ್ಷ. ಅಂಡ್ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಅಂತಂದ್ರೆ ಒದಿಯೋದು ಅಂತ ತಿಳ್ಕೊಳ್ರಿ, ಕಿಕ್ಕಿಂಗ್. ಓಕೆನಾ? ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಲೈಕ್ ದಿಸ್. ಈ ಮನುಷ್ಯ ಅವನಿಗೊಂದು ಗ್ರಾಫ್ ಹಾಕ್ತೀನಿ. ಇದು ಸಿಗ್ಮಾ, ಇದು ಟೋ. ನಾವು ಇವನಿಗೆ 1.5 ಕಿಕ್ ಮತ್ತ ಒನ್ ಸ್ಲ್ಯಾಪ್ ಮಾಡಿದಾಗ ಅವ ಸಾಯ್ತಾನ. ದಿಸ್ ಪರ್ಸನ್ ವಿಲ್ ಡೈ. ದಿಸ್ ಈಸ್ ಯುವರ್ 1.5. This is your 1.5 1.5 and 1. This person will die. ತಿಳಿತಾ? ಅವನು 1.5 ಕಿಕ್ ಹಾಕ್ಬೇಕು, 1 ಸ್ಲ್ಯಾಪ್ ಹಾಕಿದ್ರೆ ಅವ ಸಾಯ್ತಾನೆ. ಹಂಗೆ ಅದೇ ಮನುಷ್ಯನಿಗೆ ನಾ ಏನ್ ಮಾಡ್ತೀನಿ ಗೊತ್ತಾ? combination, it's all depending on combination, again I am telling you. Then if I give 1.5 kick, 1.5 kick and 2 slap, will he die or not? ಏನ್ ಅನ್ಸ್ಬೋದು ನಿಮಗ? Will he die?
No.
No, ಯಾಕ?
He has to die in sheer normal.
No, not like that. That is also correct answer, but the combination has not met ಅಂತ. Now look at here, kick is equal, that is about to die, but slap is not that. This one, if I draw it in this graph, I will check it. 2 will come somewhere here. Sorry, 2 slap means what? 2 slap is somewhere here, and 1.5 kick means this one only. Then I will get a point here. Therefore, he will die. Why? Because this point is above this line. Okay, I will give one more combination to that person. This time what I do, I will give 2 kick, 1 slap. Will he die? ಎರಡು ಒದಿಯೋದು ಒಂದು ಕಪಾಳ ಕೊಡಿಯೋದು ಸಾಯ್ತಾನ? Now I will check it like this. This is your 2 kick and 1.5 slap. Then I will get a point here. He will not die. See here, he will not die. Understood? I will give one more thing. I will increase both. Now look at here. I will increase both. This time 1.8 kick, 1.8 kick and 1.2 slap. Will he die? What do you think? No guess? The answer is, look at here, 1.8 means somewhere here, 1.8 kick, and 1.2 slap means somewhere here. This is 1, no? This is 1. Therefore 1.2 means somewhere here. He will get this point. Again, he will not die. Even though his stresses are more than the failure. This is a failure, 1.5 and 1. But even the soil is taking more than those two values, but still the soil may not be failing. Because this is all about combination. You cannot tell it by seeing the values. Okay, you have to draw and you have to get the answer. Now look at here, all the points what I am drawing below this line are safe points. All the points which are drawing are safe points, and all the points which are drawn above, they are all failure points. They are failure points. Understood now? All the points which are drawn on the line, they are considered as a failure points. Actually, this is not the failure. This is a failure points. Okay, na? Then all the points above the 5 line will never exist. They will not exist, because failure kinta innondu enaithe. You have got a failure only on the line, then what you will get above the point, above the line? You will not get any points above the line. Then what this line is considered as? What you can call this line is? This is called as envelope. What is envelope? You know, the olden days we used to have envelope from post office. No, this is a post office. This is envelope. Inside envelope you will put a letter and you will close it. This is called as a closing, or otherwise it is called as an envelope. That's why this line is considered as failure envelope. Why? Because the all points are on the line are failure, and this is also called as strength envelope. Also called as strength envelope. Why it is also called as strength envelope? Because all the points which are on the lines indicates strength also. Therefore, they are also called as strength envelope. Right? Any doubt here? Now I will come back to your doubt that look at here. What you here we got sigma 1 and sigma 3. After that we will draw one horizontal line. This is the procedure. I will draw one horizontal line and I will get one point here P. Then after that I will join this point and this point. Okay. This is considered as minor principal plane, and this is considered as major principal plane. Very interestingly, look at here. If this is a soil, and this is a graph, in this graph you have got this is a minor principal plane and a major principal plane. Then if I complete this circle, what happens? If I complete this circle, then this point P will come, this side. Therefore I will get one point like this. See here, concentrate on this rectangle. This rectangle I will put it in the direct shear test. Now you are getting the exact failure envelope, weakest and strengthiest. Now this is the minor principal plane, means I can call it as a weakest plane. Then I can call it as a strongest plane. Then this is your failure plane. Understood? Any doubt? Till now, if you have any doubt, you can ask. Irshad?
No doubt, sir.
Okay. Then we have understood completely the direct shear test. We will go further. Okay. Now to address the same thing, to address these are demerits. What are those? The first demerit is failure plane is. One more thing you always remember, failure envelope is different. Failure envelope is different and failure plane is different. For your understand, failure plane is different. Failure plane will be shown in setup, that is in the soil. Failure envelope is shown in graph. Okay, don't think that both are same. Now to address these demerits, I will have one more test, that is called as a triaxial test. Quickly I will go through the triaxial apparatus, then I will come back. Now look at here, this is a triaxial apparatus and this is called as a loading frame, and this is just vertical columns. Then here a machine is there. Inside the machine it will be applying the loads, and this is called as a triaxial cell. Then inside the cell there will be water. Therefore that is called as a cell pressure are also called as a water pressure. No? And this setup, whatever it is there here, this is your, it will give you some effective stress concepts. It will introduce, or it will give you pore water pressure, or it will regulate drainage conditions. That all will be set up inside. Understood? These are extra cells. Okay, now look at here. This is all about triaxial test apparatus. Now I will explain you how exactly the triaxial test will be there. Look at here. Here you will consider a soil sample in cylindrical form. Cylindrical form means this one. Okay. Usually the diameter of this cylinder is the D, and the height of this cylinder, or the height h, is equal to 2 times the diameter. D and 2D is your cylinder. Okay. This cylinder will be kept here. Then one membrane will be covered. This is the soil. Membrane will be covered. Above that something will be kept. Then you will apply some load here. We'll understand only this much. Okay, now then after that there is a cell here, and the cell will put some pressure here. That pressure is considered as cell pressure. That will be cell pressure. Where I have to draw sigma 1 and sigma 3. For the first test I will draw here. Tell me.
X axis.
Sigma 1 is in x-axis. Sigma 3.
X-axis.
Very good. Sigma 3 is also x-axis. Then I will get a center point here. Then after that I will draw a semicircle. Then I will get like this. Then next time I will do another experiment. That sigma 1 will be here, and that sigma 3 might be here. Center point I will get. Then I will draw one curve. Then I will get third experiment, sigma 3 and sigma 1. Then I may get a bigger semicircle. Then after that what I do, I will consider this one. I will take my scale in this way. Then I will bring this scale near to this no, this scalar near to the circles I will bring. Then I will get one common line. I will draw one common line which will be straight line. Okay, one common straight line touching the surfaces that tangential to the circles. Then I will join that one to the y-axis. When it joins y-axis, then the y-intercept is considered as a cohesion, and the angle is considered as a phi. Over. Now also you got C and phi. Now also you got C and phi. Right? Any doubt? When you get a C and phi, then you can use this equation C plus sigma tan phi equation and determine strength. Any doubt? No doubt. This is all about triaxial test. In triaxial test or in direct shear test, in both, I will get one equation here that is very important equation. Let us consider this as a failure plane, and here I will get a circle, and then I will get a semicircle, sorry, radius and semicircle. Then I will draw one line here. This is a phi value, and this is one line. This must be alpha value. Like that, I will do some derivation. Here, after doing some derivations, I will get equation sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. By heart this equation. This is the relation between sigma 1 and sigma 3, alpha and phi. That is alpha is equal to, sorry, tan alpha. Tan alpha. Alpha equal to 45 plus 5 by 2. 45 plus 5 by 2. Now, this equation is considered as a plastic equilibrium equation. Plastic equilibrium equation. Right now? Any doubt? Okay. This equation is the main equation for the next chapter. Next chapter. Do you have any doubt? That I will consider later, don't worry. Okay, now coming to the next experiment, unconfined compressive unconfined compressive strength test. Okay, unconfined compressive strength test will be, this is also called as a spatial form of triaxial test. Then the setup is same. See here, this setup is there, no? The entire setup is same. But what is the difference between UCS and triaxial test?
Cell pressure is not there.
Very good. Okay, now because the word itself is there, unconfined. Confined means what? Tightening. You are just tightening the soil with in all direction. That is called as confining. But here you don't have this confinement. Therefore, this cell will not be there, and cell pressure will not be there. Therefore, only plate will be there here. Above that, you will put a soil sample, and above that, you will put one plate and apply the load. Okay. Then this will be here, this diagram whatever it is drawn here. Okay, now this will I will draw it again. When I draw this again, then this will be your diagram. Then your deviator stress itself is a sigma 1. Then your sigma c is 0. Therefore, sigma 3 is also 0. Then your plastic equilibrium equation I will write once again. That is sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. Okay, now here this is gone. Why? Because sigma 3 is 0. Sigma 1 equal to 2c tan alpha. Then alpha equal to 45 plus 5 by 2. Then sigma 1 is what? That is a P divided by area. This is force you will apply in the top. That is P and divided by area is your this one. Then this is a 2c tan 45 plus 5 by 2. Now, can you determine C and 5 by using one thing. Okay, I will ask one puzzle to you people. Okay, if I do one experiment, the first experiment will give me that sigma 1 value as a sigma 1 value as a 0, sorry, sigma 3 value as a 0 and sigma 1 value will be something how much I will consider 2 kg per centimeter square. The next time the second experiment when I do sigma 3 I will keep it 0, then what about sigma 1 will be increased or decreased or same? The first diagram when I draw the Mohr circle, then sigma 1 is this one and sigma 3 is 0, then I will draw a Mohr circle like this, correct? Huh? Then the second Mohr circle, how it is, how it will be? Will it be like this? Will it be like this? Or will it be like this? What do you say? Any idea? No idea? ಹುಡುಕೋದ್ರಿ ಎಲ್ಲರೂ? Okay. It will not be like that. No, you will not get like this because you do that you repeat that test you repeat number of experiments how many times you want, that is you will get only one graph because sigma 3 0 sigma 1 will be 2 sigma 3 0 sigma 1 will be 2 like that. Therefore you will get only one circle, you will get only one circle. Then how to solve this equation? Any idea? Because here in this equation this is known, over only these two are known, c is unknown and phi is unknown, two unknowns in one equation. How to solve this one?
Failure envelope.
Failure envelope. Failure
Yeah.
envelope, how you will draw for this curve? Because look at here, this is there. Then how I can draw? Is there any guidelines to draw this? Is it the right way or is it the right way
Horizon
or is it the right way? Which one?
horizontally.
5. How you can say it is horizontal?
Considering C value as constant.
No, c value is constant, but you want some value, no? That value you will put, then only you will get a 5 value.
I think 5 is 0.
Huh. You may think like that. Why? Because phi equal to 0. You may think like this because UCS test will be done mostly on clay soil.
Coexistent.
Clay soil. Therefore, you may consider phi equal to 0. Means if you know the clay is this is a pure clay, before doing experiment you know already that the clay what you are handling is a pure clay, then assume that phi equal to 0 and find out c equal to, right? That is one thing. Okay, if you don't know, then if you don't know, then what we have to do is we have two options. The one is a graphical option. Graphical option is a very lengthy. I will not explain here. The another one is experimental option. That experimental option is something like this. See here, this is your more soil sample. Then you applied load here. You applied load here. Then after that, it will break like this. It will break like this. Take your protractor. Take your protractor and that put that protractor here and measure your angle. This angle you measure it. By using protractor only you measure it. You will get something value. This value is called as alpha value. It is not phi value. It is a alpha value. When you get a alpha value 45 plus 5 by 2, then you will get a phi value. See, you got phi value. Then that phi value or otherwise alpha value substitute here and get a C value. Understood? This is what you can get this one. Any doubts? Okay, no doubt. Now there is a one doubt. The doubt is this was your soil. When you apply this load, but this is a clay soil sample, no? Clay soil sample. That's why when you apply the load, this soil will not be as it is. It will bulge like this. It may bulge like this. No? The earlier area was this one, and this is your increased area. Correct? The earlier area was this one. This one I will consider it as a A0, and this increased area I will consider it as a AC, corrected area. Then corrected area is something more. How to consider this corrected area? There is one derivation. After that you will get a AC equal to A0 divided by 1 minus epsilon. 1 minus epsilon. Understood? Any doubt? Or you can consider it as a A0 divided by 1 minus delta L by L. This is your L and this is your delta L. Okay, now this is your corrected area. Therefore, your equation becomes P divided by AC equal to 2C tan alpha. Okay, this is all about unconfined compressive strength test. Now the last test is Vane shear test. The last test is Vane shear test. Now look at here. This is the Vane shear test apparatus. In this Vane test apparatus, you will see here one spring that is a calibrated spring. Then after that, you will see one mold here, and in that one you will see one vane here. Vane means what? Blade. Vane is considered as a blade. No? That this blade is connected to one rod in the center, and this rod is connected with another blade like this. Okay, now this is perpendicular. Then width of this blade is considered as a D. Why it is a D? Because when you rotate this vane with this one rod is there, no, this is extended rod. This rod you will use and you will rotate this vane. When you rotate this vane, then it will form a circle. It will form a circle. Your veins are acting like this. Then this point is rotating this way. When you rotate, this will form a circle. Then the diameter of the circle is nothing but width of the vane. Agree? You should have a agriculture. Agreeing culture is called as agriculture. Now, this is your diameter D and width of the vane. Right? Then the height of the vane is considered as a H. Height of the vane is considered as H. If you are full vein is inserted, if a full vein is inserted, that is considered as capital H. If a half vein is inserted, then that is your small h. Right? Then after that, by using this arm, you will rotate this arm, then you will apply torque. You will apply torque. At a particular torque, the soil will fail. Particular torque, the soil will fail. Then the soil, when it fails, that you note down the torque. Okay, and after that, you will be having one equation. That equation is, anyone remember that equation? The equation is T equal to pi d square tau into h by 2 plus d by 6. We have one equation. Another equation is pi d square tau into h by 12 plus d by h by 2 d by 12. Okay, now these are two equations. Okay, now this h I will write small h, means it is partially inserted, and this is fully inserted. Correct? Now from this equation, what you will get? What are knowns? Torque is known, pi diameter is known, hd is known, t is unknown, t is unknown. Either that equation or this equation. Then you got tau value. Now look at here. In the first chapter, I was explaining the property. Just remember properties of the soil. In that properties of the soil, we have two types: index properties and engineering properties. In index properties, I explained many, and after that, index properties of fine grained soil. Fine grained soil, that list was very big. In that list, you have got one sensitivity of the soil. Remember? Do you remember sensitivity of the soil?
Yes.
Yes. That sensitivity I told in there, that is, I will explain it later. That this is the time to explain. Sensitivity is equal to tau by tau. What is tau by tau? Tau undisturbed,
Field and lab.
undisturbed by remolded, or you can consider it is natural by lab. Correct? This is your sensitivity. Over. This is all about direct shear test. Sorry, shear strength. And one more thing I didn't explain. In meanwhile, I could explain that one. That is sandy soil will have C equal to 0 and phi Jindabad. Then clay soil C Jindabad phi equal to 0. C phi soil C Jindabad phi Jindabad. Right? For this curve will be like this. For this curve will be like this. For this curve like this. Over. Any doubts? No doubt. Now the time is 9:56.
Sir,
Ah,
Like, how do we select which experiment to be performed for particular soil?
Correct. For that we will go through this once again. Okay. Look at here. Direct shear test. I told you that we want three lines, that one common line. Then after that you will get a C and phi value. Okay. 3 points, is it a minimum or only 2 points is enough? Yes. 2 points are enough. 1 point and 2 point. 2 points are enough. Okay. Can you make this two tests instead of two tests? Can you make only one test and do the find the C and phi value? That is also possible. When I will draw 1 point, then how to get a inclined line, whether this line or this line or this line, like that. For that one I will say 1 point is here in the origin. Then origin means what? C equal to 0. Then C equal to 0 means this is your test. Means what? If sand is there, you already know that C equal to 0. Therefore do direct shear test. Then only one test is enough. Then 1 point is already here. Then you will get here. Then phi value will be determined. Therefore I'll say direct shear test is very good test, or that quick test for sand or granular soil, right? Next one is unconfined compressive strength test, because now only you told that clay is there, that's why phi equal to 0 we can assume, and this test is called as unconfined. And if you use a sand, then it will not perform because sand will collapse. Therefore unconfined test, then clay soils you can use. Therefore UCS, then clay sample. Then triaxial test, both you can use sand also, clay also, and both C5 soil also. But usually sand is there for direct shear test, therefore they will not perform this one here. A clay or C5 soil you can do it for by triaxial test. Understood? Now after that also there are some drainage conditions also. Here sand direct shear test we can do only undrained test, and triaxial test, this is direct shear test, and triaxial test we can do undrained and drained also. UCS test we can do undrained only. Then direct shear test you can do drained also, but with some complications. Any doubt? No doubt? Okay. If you don't have any doubts, we'll stop this chapter here. Now it is 10 o'clock. We'll come at 10:07. Now we will be discussing about earth pressure. Earth pressure. Now look at here. First we will understand what is retaining wall. See, this is your retaining wall, the shape of the retaining wall. And why we want retaining wall, that we will understand. This is a soil surface. This is another layer. So let us consider this is one hill. Okay. I want to build a home on this hill. How to build a home on this hill? May I build like this? Home? No, this is wrong. Then I have to make a leveled surface and I can build. Then there are two ways to make the level. The first one is I will construct one wall here. Then I will bring the soil from somewhere and I will put here and make this level. Then I will build my home. Right? This is one way. The other way of building this retaining wall is if you are building this one hill is like that, then I will cut this hill this way, and I will cut this hill this way, and I will build one wall here, then I will build my home here. There are two ways. This is also retaining the soil, and this is also retaining the soil. Therefore, wherever you want to maintain two different levels, this is a one level and this is the another level. You want to maintain two different levels, then you will build one structure that retains the soil, that that retains the collapse of the soil. Then this wall is called as a retaining wall. Understood? Now you got the meaning of retaining wall. And next, I will give you one example. You have to answer me. Like there is a one person, here, and this person on his head, I will put one box with a hinge here and hinge here, and I'll put a soil here. Now he will hold that one with his hand, not here. He will hold with his hands here and his another hand here. Now tell me whether his head will be carrying more load or whether his hands are pushed by more load. This is sigma V and this is sigma H, or both will carry same load. What is your opinion?
Sigma H will be more.
Sigma H will be more. Okay, what about others?
Sigma V will be more, sir.
How?
Due to gravity.
Okay, sigma V will be more. Okay, now we'll go through that one. We'll see the answer. Now look at here. This is the particles, and these all particles are one over the other. Then I will get the entire mass acting to this surface, right? Then when I have these particles here also, then again this mass will be there here. But this particle, let us consider this another particle and another particle, and if this particle is there, now this is leaning on this particle, this is a lean, and this is also leaning on this particle, then its weight is vertical. Now the leaning is more or vertical force is more, then obviously the vertical force is more than the leaning force. Understood? Means a small portion will be there because there is a cohesion also. There is a cohesion also, there is a friction also. Considering all these parameters, vertical force will be more than the leaning force. Therefore, we will be having sigma V greater than sigma H. Means this sigma V and sigma H are somewhat, they have some relation, but V will be more and H will be less. Okay, now I will give you another example. You have, this time you have to give correct answer. Another person is there, on his head again the same hinged box is there. In this one I will put this time water, full of water. Then this person will hold one hand here and another hand here. Now tell me sigma H is more or sigma V is more? Hmm.
Sigma H will be more.
Sigma H will be more. What about others?
I think both are same
Why?
because water pressure will remain same in all directions.
Very good answer. This is given by the scientist name. Who told this?
Lakshmi.
Pascal.
Pascal, scientist name I am asking. Sorry. Okay, this is told in this class by Lakshmi, but exactly it is told by Pascal. Right? Okay. Now, according to Pascal, the load acting in all direction is same. Means According to Pascal, this horizontal pressure no need to calculate. That's why in fluid mechanics we have not concentrated like horizontal force, vertical force. No. But in when we come to the soil mechanics, then in soil mechanics again you consider these two words: soil mechanics and fluid mechanics. Both are mechanics, but horizontal and vertical force are same in fluid mechanics. Therefore, we are not worried about that. But in soil mechanics, these two forces are different. That's why we have introduced earth pressure. The meaning of earth pressure is horizontal pressure. Now I have to establish a relation between this horizontal pressure and vertical pressure. For that, common sense says that if a retaining wall is like this, the retaining wall is like this, then this soil is here, then this soil will push the retaining wall away from the backfill. Now this retaining wall move in this direction. Correct? Okay. Now this is considered as active earth pressure. Active earth pressure. Why? Because this is actively pushing this retaining wall outwards. Therefore, it is active earth pressure. Right? Now, the same thing, there is another pressure. This time, the wall will push the retaining, the backfill. This wall will push means this wall will move towards the backfill. Can you give me an example where wall will push the soil? Hmm? No idea? Okay, look at here. The wall will push this one means there is something more than this soil. Something more material must be here, or more dense material must be here, and this dense material will push this wall this direction, and now in turn this wall will push this soil. Now here what I can say is for this soil it is a passive earth pressure, and for this soil it is the active earth pressure. Means what? Active earth pressure means moving away from, and passive earth pressure means moving towards the backfill. And we have one more retaining wall. There are some type of retaining wall where we will get this wall will not move either towards or away from. Can you give me an example where wall will not move but still the wall is experiencing pressure? Wall has a pressure but it's not moving.
Equal equal
Same,
load on both sides.
Load on both sides, but
same stress.
no, it's not required. No, say
So,
for example, here soil is there and here soil is there. Why you want wall in between?
homogeneous.
No. The examples are this wall is firmly what firmly founded, or this wall is connected with another beam, and this beam is connected with another wall. Now this is somewhat box culverts are there, no box. Now there is a soil here. This soil will, of course, it will push this this wall, but this wall will not move. Why? Because that is restrained. Now this wall is designed with the at rest pressure. At rest pressure. Another example is you can draw this diagram. Look at here. This is a retaining wall with the base this much, or cantilever type of retaining wall. You have observed cantilever type of retaining wall like this. Then the soil will be filled this much. Okay, na? Now whether this retaining wall will move away from or towards backfill? No, it will not move at all. It may bend like this. It may bend like this, but it will not move. Therefore, this wall is designed at rest condition. Therefore, this is very important because most of the students can feel the meaning of active and passive, but at rest means cantilever type retaining wall or basement walls. Basement walls or box culverts are designed for at rest earth pressure. Understood? Now, this earth pressure theory first studied by Rankine. Rankine. Okay. According to Rankine, because he studied first means he will make so many assumptions. The first assumption he made is soil is sandy type of soil or granular soil or cohesionless soil. Cohesionless soil means he considered C equal to 0 soil. The second one, he considered the back of the wall is smooth and vertical. This back of the wall is there, no? This is a smooth and vertical, but in reality it won't be, but he considered like that. This is a smooth and vertical. Right? Then another thing he considered is the ground surface. The surface is horizontal. The surface of the soil is horizontal. The another thing he considered is plastic equilibrium condition. Now look at here. When I say plastic equilibrium condition, then you should, in your mind, this equation must pop up. Sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. This is plastic equilibrium equation. Right? These are the main assumptions done by Rankine. That soil is homogeneous and isotropic is a default assumption in geotechnical engineering. Then after that, now I will consider active case. Active case. When I consider active case, look at here. This is your retaining wall, ground. This is ground level and base level. Then this wall moves away from. When it moves away from, now look at here. This much soil A and this B and C. This portion of the soil will move away. When it moves away, then it will slide down. When it slide down, then the reaction will be upward direction. Then the same thing, this will come down. Then the friction will be upward, if any. Okay, this is what. Then in active earth pressure case, then this angle, this failure angle alpha is equal to always 45 plus 5 by 2. 45 plus 5 by 2. Okay, now I will consider a small element inside. This is your sigma v and this is your sigma h. Now tell me which is more, sigma v is more or sigma h is more? You already answered this one, that sigma v is more. Therefore, I will consider that this as sigma 1 and this one as a sigma 3. Then when I consider these two, then I will substitute in the equation sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. Then in this one, according to assumption, this is 0 and the sigma 1 means sigma v equal to sigma h tan square alpha. Then after derivation, the sigma 1 and sigma, this sigma, I will write it, don't worry. Sigma h divided by sigma v is nothing but 1 divided by tan square alpha. Then we have to have this equation, that is a coefficient of active earth pressure is equal to sigma 1 by, sorry, sigma h by sigma v. This is constant, whether it is active or whether it is passive or it is at rest. In all three cases, this is constant. Then here you can see this is somewhat the same nature. Therefore, Ka equal to 1 by tan square alpha. Mathematically, Ka equal to 1 minus sin phi by 1 plus sin phi. Right? This is active earth pressure. Then in the passive earth pressure, what happens? In the passive earth pressure, you will have a retaining wall this way. Then the ground level, base level. Then failure surface will be something like this. Then this value alpha equal to 45 minus 5 by 2. When it is 45 minus 5 by 2, then you will consider one small element here. This is sigma h and this is, sorry, sigma v, this is sigma h. Now be careful, be careful, that is this time this is less. Therefore this is sigma 3 and this is sigma 1. If you have any doubts, you can raise. Otherwise, I will assume that you understood sigma 1 and sigma 3. Then after that, I have an equation sigma 1 equal to sigma 3 tan square alpha plus 0, that is 0. then sigma 1 is sigma h, then sigma 3 is sigma v tan square alpha, then sigma h by sigma v is nothing but tan square alpha, that is your Ka. Therefore Ka mathematically 1 plus sin phi by 1 minus sin phi. Right, sigma 3 tan square alpha plus 2c tan alpha, that equation I cannot take and explain this one here. Why? Because this is elastic equilibrium. Elastic equilibrium means I have to bring one of these mu k e g, one of these I have to bring. That's why someone has derived this equation, that is k naught is equal to mu divided by 1 minus mu. This is your k naught equation you can consider. Or sometimes some empirical formula is there. Empirical formula means what? Some scientist has done many experiment on that, on this in this trial, and he has concluded that k naught equal to 1 minus sin phi. You can remember either this equation or this equation for k naught calculation. Right? Then what is the meaning of this k naught? Why we have to calculate k naught? Why we have to calculate k naught? Because always we will be knowing vertical stress but not horizontal stress. It is very easy to determine vertical stress. Why? Because if you are interested at this point, then what is the vertical stress? Then just get the height h, then multiply this h with gamma, then you will get the vertical stress over. But how to get a horizontal stress? Don't know how to get a horizontal stress every time. Therefore you have to calculate this sigma h is equal to k into sigma v. Then what is this k? K is your, either it is ka or kp or k naught, then that is multiplied with sigma v, then sigma v is your gamma h. Therefore ka gamma h is your sigma v always. Now think of variations, how this is varying. That if you think, then you will come to know that the power of this one is 1, and the variable is which one? This is constant, this is constant, then variable is this one. The power of these two is 1. Therefore you will get a linear variation. Therefore you will get this one as a linear variation, not parabola nor cubic, okay, nothing like that, curve. This is just linear. Why? Because this power and this power is 1. Understood? This is over. Now let us consider this is your retaining wall, and you want to draw a stress distribution diagram. Then you will consider here as a 0 because h equal to 0 and here h equal to maximum. Then this is your earth pressure distribution. Okay, this is at every point there is a different of stresses. Here 0 is there, here this much is there, here this much is there, here this much is there, like that it is increasing. And the bottom, how much it is? Gamma into capital H, that is multiplied by K. This is your this one. Then what about the total stress? Means all of them combined together, they will be acting at one particular point. No, that particular point the load will be capital P. This capital P is equal to area of this distribution, half into base into K gamma H, half into base into height. Then where exactly it is acting? It is acting at a distance of h by 3 from the bottom. Right? Now who explained this one? This everything is explained by Rankine. Now let us consider there is a retaining wall this way, and we have water table here also. The same thing, water table is also there and soil is also there. Now may I write like this, because this is a saturated soil, no? Saturated soil. May I write like this? Ka gamma sat into H. Is it right or wrong? Can anyone explain?
No.
Why?
It should be gamma submerged, sir.
Why gamma submerged? Why not gamma sat?
Because water pressure should not be multiplied with the Earth pressure coefficient.
I.
Um,
Why we should not multiply? You should answer no. You are the Pascal. Huh? Now look at here.
Meg.
Because the Pascal says that sigma v equal to sigma h, and this person will write like this: sigma h equal to sigma v Pascal, and Rankine says that sigma h equal to k into sigma v. Then according to Rankine, k is nothing but what? Sigma h by sigma v. Then according to Pascal, k is nothing but 1 is nothing but sigma h by sigma v. Then here we are not multiplying, no, that we are also multiplying, but that is 1. That's why we will remove water from here and will make submerged. And after that, here 1 into gamma w into h. Right? This is 1 into gamma w into h. Here we are multiply, but we will ignore it. 1 is there. No? That's why we will not write. This is your earth pressure. That's why whenever we are calculating earth pressure in a submerged condition, then up to the level of water, the water pressure, vertical pressure is not multiplied with the k or multiplied with 1. Then we will get a answer. Then after that you will calculate 1p here, that is you will call p1, and another area is here, therefore you will call it as a p2. Then p1 plus p2 is your total p. Total p. Right? Now, can you explain? Can you give this reason exactly the answer? If this is the same level here, sand is there. Here sand is there, and here water is there. Same level, both are in the same level, and wall is here, and which is not founded. Now stand of phi equal to 30 degree, and this is the water. Now tell me, this pressure is more or this pressure is more, or this wall will move towards what? Towards A, towards soil, towards water, remains same. Which option? Option D, none. Others, guess the answer. Irshad?
Sir, I think towards soil, sir.
Towards soil.
Or
Why?
so water the voids of the air angle, sir. So pressure H here.
No, no. Give me theoretical answer. Theoretical answer. By knowing equation or something like. Okay. Look at here. For this one, whenever Aruna,
I think for water, K will be equal to 1, and so
very good,
total
very
force
good.
will be.
Very good. Okay, na? By using a K value only, because at this time I am giving you water and sand comparison, therefore it is very easy to compare, or you can use common sense. Or sometimes if some other sand 1 and sand 2 is given, then also you have to answer. No, that's why you calculate K for this one, that is always known 1, and K for this one, that is 1 minus sin phi divided by 1 plus sin phi. Sin 30 is a half, therefore 1 minus half is half divided by 1 plus half is 3 by 2, therefore the answer is 1 by 3.33. Then K value is less here, K value is more here, therefore obviously this force will be more and this force will be less. Okay, therefore this will move this side. The wall will move towards the sand. Correct? You can compare in this way. This is all about a Rankine's assumption. Rankine's assumption, that is C equal to 0 soil. Today I am extending it half an hour. I think there is no problem. Okay. If anyone has some little problem, then after that recorded video you can watch. Okay, we'll continue. C equal to 0, because Rankine's assumption is C equal to 0 he has considered, and but we have asked what Rankine if C is not equal to 0. Then he said that don't worry, we will go with the plastic equilibrium equation only, because active and passive earth pressure we have that equation. Sigma 1 equal to sigma 3 tan square alpha plus 2c tan alpha. Okay. Now in this case what? The same thing, this box you will consider sigma 1, sigma v it is, and this is sigma h. Sigma h is our sigma 3 and sigma 1 is your sigma 1. Sigma v is your sigma 1, and that we will substitute here, but this time c is not equal to 0. C is not equal to 0 means sigma 1 itself is sigma v, that is sigma h into tan square alpha plus 2c tan alpha. Means no derivation is required. This much we will stop. Why? Because we are interested in sigma h, and that is there in this equation. And if you want, you separate it. Sigma h equal to, you write it something differently, some dividing and multiplying, you will get one equation, that is sigma v cot square alpha minus 2c cot alpha. 2c cot alpha. But here we wonder here why we got minus. Is there any significance? Okay, I will write it gamma h, sigma v means gamma h, cot square alpha minus 2c cot alpha. Now in this case, why this minus is there? Is there any significance of this minus? If I check, look at here. This is our retaining wall, and this is the top surface. At this surface, h equal to 0. Agree? This is h equal to 0. If I substitute h equal to 0, what happens? Put h equal to 0, then your sigma h equal to, this is 0 minus 2c cot alpha. Okay, means here I am not getting any 0 value. Check. The earlier case I used to get this distribution starts from here, but this time it is minus. Minus means it is tension. In soil, minus means tension. Therefore, you will get a curve like this. Means some portion you will get in a negative way and some portion you will get a positive way. What this negative way indicates is, this is your soil condition, and this particular line is pulled this much, pulled this much, pulled this much, pulled this much, pulled this much. This is pulled this much, this much, this much, this much, this much. Then what it results? This results a crack. The soil is pulled here, the soil is pulled more here and pulled less here, therefore you are getting crack. That's why the c is not equal to 0 soil, or you can consider it as a clay soil. The clay soil best example is BC soil, black cotton soil. Therefore the black cotton soil, the surface in summer season, okay, in summer season black cotton soil will be something like this. No, cracks will appear in the black cotton soil. Even you can observe the very big cracks will be there. Why? Because the top surface is subjected to tension. The top surface is subjected to tension. Then the question is, can we measure the depth of this crack? Can we measure or estimate the depth of this crack? Yes, we can measure this depth of the crack. Write it down. H crack is equal to, H crack is equal to 2c divided by gamma into tan alpha. This is your H crack. Right? Now, very interestingly, this is your retaining wall, and here you have got this structure. Right? Now, what is this? This is your H crack. H crack. The same triangle, if I resemble here, that is that overlap here, then I will get one more H crack. H crack. Then together, both together, I will consider it as a H critical. H critical. Okay. Why this is called as H critical? Because here, look at here. I will use black color. This top one will apply the force this direction, and the bottom small triangle will apply the force in this direction. This force magnitude and this force magnitude both are same, and both are opposite to each other, therefore they will cancel. They will cancel, and this bottom portion will have some force. This force will push the wall, therefore your retaining wall this much is enough. Means in clay soil you can build a retaining wall this way. See, this way you can build the retaining wall. Means the top portion here retaining wall is not required, because these forces they will fight each other and they will stand there only. They will not push your retaining wall. That's why in roadside you might be seen that there is a big hill like this, but they will construct only retaining wall this much. They will not construct the entire thing. Why? Because this is a cohesive soil. This is cohesive soil. Then your vehicles will be moving here. Okay, now this is, then what is a H critical? This H crack you already know, that is depth of the crack 2c by gamma into tan alpha. Then H critical will be 4c by gamma tan alpha, just double. Okay, and this is unsupported height, they will call unsupported height. Unsupported height. Unsupported height also you can call it as a H critical. Right? Now the last one, today's last topic, that is, till now we have assumed, we have discussed about Rankine's theory. Rankine assumed that C equal to 0 soil, vertical wall, the back of this one is vertical, and friction is 0, smooth, no? Friction is 0 and vertical, and ground surface horizontal, ground level horizontal, and he considered the wedge failure. Wedge, non-wedge alla, wedge failure. Wedge failure means he considered how retaining wall is there. This was his retaining wall, and after that he used to draw one line here. Right? One line. Sorry. He is not considered a wedge failure, non-wedge failure it is. He considered a single elementary failure. Elementary failure means what? He used to consider a small point, and after that he used to apply the force and he used to study. He derived all the equation by considering a small element here. A small box element he will consider and derive the equation. Therefore, he is considered as a elementary approach. Elementary approach. Okay. There are some merits and demerits about this theory. These theories were addressed by Coulomb. Then Coulomb's theory on retaining wall will come. Coulomb says that not only C equal to 0, you can consider C equal to 0 soil, phi equal to 0 soil, and C5 soil also. But he also concentrate more on C equal to 0. But you can implement this technique here also. Just you remember both are similar. And after that, this Coulomb considered not only vertical, you can give me a retaining wall this way also, he will deal. The retaining wall with this also he will deal. And even the ground surface also not to be horizontal, even the ground surface is like this, then also he will deal. Who? Coulomb will deal with this type also. And not only this one, the Coulomb will deal with the friction also. Here there is a friction back of the wall, then also he will deal. But according to Coulomb, that failure wedge is whole wedge he will consider. His theory says wedge failure. Wedge failure means he is not considering the element. Means he will say that one force acting here, the wedge weight will be here, the force from here will be here, and these three forces are in equilibrium. These three forces are in equilibrium, like that he will consider. Okay, na? Therefore, it is a entire wedge is considered for the failure. Therefore, these are the difference between these two. And how to determine the Coulomb's earth pressure, I think that is not included for diploma level students, because here graphical methods will come, Raybon's graphical method and Kalman's graphical methods. I can say these two are outcomes of this Coulomb's equation. Right? This is all about earth pressure theory. We'll go to the earth pressure theory. What they have given, They have just given here earth pressure theories, active earth pressure and passive earth pressure. But we have discussed even at rest also, and Rankines and Coulombs also we have discussed, so that it is completed. Then at the top, shear strength, direct shear, vane shear, triaxial is over. Okay. Is there any doubt? Want to discuss anything? Intelligence I will give in the three different levels. There are three type of students who are appearing for competitive exams. The first level of intelligence is common sense. This is called as a primary level of answering. Always first time students will be answering with their common sense. But this common sense is not well matured common sense. Therefore, most of the time, whenever I ask students giving only two options, give me answers in yes or no, then students will definitely they will give the wrong answer. Therefore, your unmatured common sense will always give you wrong answer. For this one, my suggestion is don't use your common sense for answering the question. Then what you have to do? Use theory. Use theory. Find any equation, find k value, find the sigma value, think in a theoretical way, think in a some concept scientists and his theory, then you go on answering this one. This is the second level of intelligence. Then this level of intelligence will be more matured than this person, right? Then after that, the third level of intelligence will be coming back to common sense. Now, when you solve many problems with theory, or when you understand a complete theory and perfect theory, then again you will start answering with the common sense. Now, this common sense I will call it as a highly matured common sense, or otherwise knowledgeful common sense. Geotechnical expert will not calculate k value or sigma value because his common sense is perfectly trained. Therefore, this is the next level of intelligence. At this time, he will not make any mistakes.